Climate change is getting worse, it's happening everywhere, and it requires immediate action. These are just a few of the takeaways of a recent UN report compiled by hundreds of expert scientists from around the world. You've probably heard about it.
We are on course for devastating changes to our climate.
According to the latest report by the most authoritative body on climate science,
it is now or never.
We are on a fast track to climate disaster.
This is Dive In with NOAA Fisheries. I'm John Sheehan. The Intergovernmental Panel on Climate Change, or the IPCC, released the report and is the United Nations body that assesses the science related to climate change and presents actionable information for the world's leaders.
This report lays out very clearly the things we can do and how they are effective.
What are the solutions to reducing CO2 emissions? That's where we need to focus.
That's Dr. Kirstin Holsman and Dr. Libby Jewett, two of the authors of the IPCC report and my guests today. We'll talk about not only the very real challenges, but also some of that actionable information. Dr. Holsman is a research fishery biologist and the co-lead investigator on the Alaska Climate Integrated Modeling Project, which is evaluating the impact of climate change on the Bering Sea. Dr. Jewett is the founding director of the NOAA Ocean Acidification Program, which examines how the chemistry of the ocean is changing and the impacts of these changes. Dr. Kirstin Holsman and Dr. Libby Jewett, welcome to Dive In with NOAA Fisheries.
Thanks so much for having us. We're really excited to be here today to talk about the report.
Ditto. Very excited to be here. Thank you so much.
The latest portion of this IPCC report has just come out. Can you give us a brief overview of the big takeaways of the report?
Yeah, absolutely. The report is an extremely comprehensive analysis of all the climate impacts to date and responses that have been effective over the last 7 years. We've been reviewing information from the last 7 years. And the report is very clear on a few topics. Firstly, climate change is happening. It's having measurable impacts on every sector in North America, in every sector of the world. There is no region of the world or ecosystem or city or location that hasn't been impacted. The other thing that is really evident from the report is that there's immediate need for action on climate change, specifically planning, investing in climate planning and preparation, investing in technologies that can help us adapt in the future to increasing climate impacts. The other thing that the report points out is that those responses, our ability to adapt to climate change, is effective now, but it's limited as we go forward by the degree of change we may experience. So it's really important to couple global carbon mitigation policies and planning and preparing for climate impacts.
Just to reiterate, evidence shows that climate is affecting every part of life in North America, really everyone. Food production and health and access to fresh water, work, commerce, trade, winter sports, outdoor labor, ocean, mountains, lakes, plains, cities, rural areas, coastal areas, and indigenous communities. All of these aspects of our life in North America are being affected. You know, we are adapting, humans are adapting, and people in North America are adapting, but that adaptation will be better if we can be better coordinated, better planned, and planned across different kinds of impacts. So, for instance, not just planning for the next hurricane, but the fact that the hurricane might be followed by a tornado and then flooding. Like, we need to be planning across many different aspects of our life in order to really be prepared.
Yeah, it's everything, which can almost stifle the imagination. It's not just hurricanes. It's then you've got to go to the store and buy bread that might be more expensive.
Yeah, exactly. Those compounding impacts of climate change are a huge challenge. And the successive repeated hits on systems. So the marine environment, the oceans, are a place where we're seeing those compound impacts very clearly because the systems respond very quickly to things like a marine heat wave. So a marine heat wave comes in, moves species really quickly. That has its own cascading impacts on livelihoods, on predator-prey dynamics, on where whales migrate. So there are these compounding impacts that are happening very rapidly in the marine environment in particular.
Yeah. Can you talk a little bit more about some of the specific ocean impacts?
We're continuing to see the impacts of some of these punctuated events. So marine heat waves are probably the most well-documented or well-known event. They've been taking place in every one of our large marine ecosystems in North America, increasingly strong and increasingly extensive. So they've been occurring over large areas. And when that happens, species can move in response to the warming events. They can try to get out of warm water. But when they're that extensive and they go from the surface all the way down to depth, there's very few places where fish can go. So they're moving as fast as they can. But we've also seen that impacting the food webs. And that's the piece that takes a little bit longer to see how these impacts play out. You're taking this very complex ecosystem with all these species that are connected together. People are part of that, they're connected as well. And then you're squeezing parts of it with these events. And so one of the things that we see are these sort of rippled effects through an ecosystem that emerge over time. So you get the initial species responding, maybe they move, maybe there's a collapse. And then a year or two later, you might see another species start to collapse. You might see upper trophic species at the top of the food web start to suffer starvation events of seabirds, whales, and things like that. We've seen those as well. But then you also can see some species being released from predation and increasing. So young juvenile fish like sablefish in the Gulf of Alaska, they actually increased during the marine heat waves because there were no more predators in the system. So whether or not that's a permanent change or a punctuated one-time response, it's hard to tell until you monitor the system over time. And the magnitude of the change we're seeing is unprecedented in many cases to anything historically that set up these systems. We are seeing places like the northern Bering Sea, for example, that are undergoing change from a Arctic system to a boreal system. So we're seeing shifts, whole ecosystem shifts. And it's uncertain how that will play out and how well we can adapt to those changes as well.
And I think that's one of the hard perception problems because it's happening so much in a place that we don't live and can't sort of grasp the magnitude of it. Can you sort of paint that picture?
Yeah, I think, it is hard if you're not someone who spends a lot of time on the water. Folks that are living in coastal environments and people that rely on marine resources for their livelihoods, for their well-being, for their survival. I think they do see these impacts. It's one of the things that struck me when I first started working on climate change is I expected to have to explain that climate change was happening to fisheries and folks who are out and fishing in the Bering Sea. And I didn't have to. They knew and they wanted to know what were the solutions. What can we do and how can we prepare for this? And so it's sometimes hard to see it just looking out over the ocean. You don't see something like you would see if you had a drought in an area and everything dying. But if you go below the surface and you start to look at how ecosystems used to look, I think the most apparent one that people are probably aware of is coral bleaching, the impacts on coral reefs that happen when water warms up. It's very apparent when you go into these systems. And so for some of the regions where we have a lot of data that goes back a long time, you can see the signal in the data. You can see this is when it got warm. I work in the Bering Sea, so it's a place where seasonal ice comes down in the winter, covers the whole system, makes the water really cold. There's like a thumbprint of memory of where that ice was in the summer. Even though the ice melts, it's still cold where the ice was. Well, we've been watching that cold pool for years, and you can just see it like getting smaller and smaller and smaller till almost non-existent in 2018. And it's come back since the heat wave, so it does come and go, but the extent of that cold pool was so tiny in 2018, and the species, where they went in the Bering Sea, totally changed. And it's a huge area. So the Pacific cod moved, they moved all the way, they moved 1,000 kilometers north in a year. I mean, it's a massive migration. And so there's just these very startling responses. When you look at the biology, you can really see the signal of it.
The report makes a big point of emphasizing adaptation and preparation. In other words, things that, yes, humanity has to stop doing certain things, but it also has to prepare for these events because they're happening no matter what, and it's time to to accept that. Can you give me some examples of adaptation or a preparation in your areas of expertise?
So my area, of course, is ocean acidification, and I think a really strong case for adaptation is the work that we've been doing together with the shellfish industry. So the collapse in the ability of oyster growers on the West Coast to actually grow up baby oysters in their hatcheries was seriously compromised in the mid-2000s, and it was only through sort of collective scientific sleuthing, which included some of our NOAA scientists, that we determined that the hatcheries were actually pulling in water to feed the baby oysters with corrosive water, which was now corrosive as a result, again, of this larger scale of, carbon dioxide being taken up by the ocean and then upwelling along the coast in the Pacific Northwest. And so by realizing that, we've since worked collectively with the shellfish industry to develop new techniques for them to be able to monitor the water. So this is definitely a good news story for the industry that we've been able to develop these scientific tools for them to be able to adapt to the changing conditions.
Aren't there forms of aquaculture that actually improve ocean acidification?
If you're growing seaweeds, for instance, actually, yes, they would. And there is actually a growing industry around seaweeds that can be used for food, for fertilizers, and for other things. And because seaweed actually takes CO2 out of the water and puts oxygen back in, that's actually being explored as an approach not only for growing food, but also for improving the OA conditions in the waters. And their efforts around this, both in the Pacific Northwest and also, I think, in Alaska and in Maine. There are scientists that are looking at this as an opportunity to, actually do a couple of good things at once.
Yeah, that's one of the things in the agriculture section that we found to be pretty exciting is the sort of a movement towards thinking of integrated food systems for North America and how you can kind of reap these multiple benefits by just coordinating across things like aquaculture and agriculture and fisheries and aquaculture. So there's connection points there that have been there all along, but if we enhance a few of those, then we can really do a big step towards adaptation, but also a step towards mitigation.
Would another example of that be something like habitat renewal, where you're improving upon, say, wetlands, and that has the benefit of improving the environment, but also, creating a fishery potential for communities?
Yeah, I'm really excited you brought that up, actually, because one of the other key themes from this report is around nature-based solutions. So how you can use the sort of natural processes of nature, which take a little bit of investment up front. It takes a little time to get off the ground, but once it's going, it's self-perpetuating. So a great example is coastal restoration, because coastal restoration can protect shorelines from storm inundation. It creates that sort of basis for biodiversity, those interconnected pieces of an ecosystem. So if you lose one species for a little while, it doesn't collapse the whole system. You have redundancy in the system. And so, yeah, nature-based solutions, there's wonderful examples from the marine environment on this, but it also does cross over. It's cross-sectoral and gets into what do you do with upland watersheds, how do you develop along the shoreline, and then what do you do in the ocean environments.
Yeah, I'll add another reason that it's really important that we restore and protect actually what we have in terms of those coastal ecosystems, particularly wetlands and marshes, is that in many regions we're likely seeing and are going to see increased precipitation. And as freshwater, sort of runoff increases, you also get a lot of nutrients running off the land that may be from urban areas, it may be from agricultural areas. And by having those wetlands and marshlands, you're actually keeping more of that nutrients kind of in the coastal system so it doesn't end up causing dead zones. Additionally, if the protection of coral reefs, there's pretty strong evidence that areas where there are coral reefs, If you have storms like hurricanes, coastal areas are more prone to being affected by those storms. But if they have coral reefs just offshore that are absorbing some of that activity that's coming in with the storm, it actually reduces the impact on the human communities that are just inshore.
Kirstin, you're co-lead investigator on the Alaska Climate Integrated Modeling Project. Can you tell us what is climate-informed modeling?
Yeah. So we're really excited about this project. It's a huge collaboration across multiple disciplines at the Alaska Fisheries Science Center and our university partners. We've come together as oceanographers, as biological modelers, as ecosystem modelers, as social and economic modelers, and all come together to try to sort of test climate-informed management tools. It involves taking a lot of these projections for the ecosystems, things like on a weekly basis, what is the temperature at the bottom of the Bering Sea? Where is the sea ice? Which way is the water moving? We can connect that then to what we know about where larvae and juvenile fish live and how fish are foraging. And then we can apply a simulated management to that system and say, well, if we used our current management system, how does that perform in these really extreme future scenarios? So we have somewhere it looks a little bit like today and somewhere it's much, much warmer in the future. And how does that management perform? And then we're hoping that that will be a good model for the kinds of planning and tools that can be implemented in other regions of the nation.
Yeah, you're talking about creating a system that can track a whole lot of variables and be able to say, well, if we do a little bit more in column A, what will the impacts be across all these other variables?
Exactly. Yes.
And Libby, as director of NOAA's Ocean Acidification Program, you're contributing to a lot of that data and defining those variables.
Very true. But we're still really, I would say, in the early stages of figuring out exactly how ocean acidification is affecting marine resources. Through my program, we actually fund our Fisheries Science Center colleagues like Kirstin, who then do laboratory experiments on, the different components of the ecosystem, including, from fish to crabs to phytoplankton to copepods, to figure out where the vulnerabilities are, which we then will be able to eventually, I'm not saying it's happening now, build into these adaptation modeling scenarios that Kirstin was talking about.
I think that's one of the things that's so exciting about the research that's taking place right now at NOAA is that we're drawing from every branch and every component. So we're bringing in climate forecasting and weather forecasting and near-term projections and forecasts, all the way to as Libby was talking about, these laboratory experiments that tell us exactly how species respond to temperature and then OA, and then the two combined, which is really important, those interactions. And then we can put it in a model and we can use it to help inform fisheries advice.
This report is certainly not the first to sound very loud alarm bells. I'm wondering how difficult or challenging it is to sort of communicate the immediacy and the importance of these reports to an audience that could be growing more and more fatigued just from hearing them kind of frequently.
Yeah, I think it can be hard to talk about climate change without getting very disheartened. So it's very easy to take a look at this huge problem and feel like there's nothing really that can be meaningfully done. And so my hope is with this report, because it lays out very clearly the things we can do and how they are effective, and we know what we need to do and we can implement it today. We probably should have done it 5 years ago, but we can do these things today that will really make a huge difference for how climate impacts us, and will make a huge stride forward towards the solution. So there is hope. I think Libby and I would describe ourselves as optimistic people because there's an understanding climate change is happening and people know that. And now we have so much information. There's such a wealth of information and knowledge about what we can do that the key is to help communicate very clearly steps A, B, and C. And it starts with investing. It starts with coming together and collaborating. It starts with communication and participation and being inclusive of as many perspectives in that in decision making as possible, because that's really important. We have to kind of do it right the first time, right? We don't have a lot of time for trial and error. So we need to bring as many people into the discussions around solutions as possible so we can come up with the right one, put it in place and do it. And people can move fast when they need to. So I have hope that will happen. But it is always a challenge to confront the overwhelming aspect of this problem.
Yeah, my understanding of the history of the IPCC is that in the first round, which was back in 1988 or so, they really only focused on the physics and the chemistry and thought that would be what people could and would respond to. And frankly, people don't necessarily really care about, temperature and chemistry and things like that. They don't know how to relate that to their life. And so we're focused on the impacts and the adaptation that's happening and the good news aspects of that Kirstin was referencing. And what I'm really excited about is the mitigation, the science of solving the problem. Like, what are the solutions to reducing CO2 emissions? That's where we need to focus. But I think we only have to look at relatively how quickly humans came up with the COVID vaccine to know that we will figure this out. But we need to figure it out now and very quickly. I think that's the take home from our report. We are not going to be able to adapt our way out of climate change. We have to do both. We have to reduce CO2 emissions and we have to adapt. And we will only be successful at adaptation if we are also reducing emissions, because there's a good chance it's going to start accelerating to the point where we can adapt to it.
Well, Dr. Kirstin Holsman and Dr. Libby Jewett, thanks so much.
Thank you. Thank you so much for having this conversation. And there's a lot to do, and we want the world to get started too.
Yes, I agree. And so glad that you're getting the word out. Thank you.
Dr. Holsman is a research fishery biologist and the co-lead investigator on the Alaska Climate Integrated Modeling Project. Dr. Jewett is the founding director of the NOAA Ocean Acidification Program. You can read a lot more about the IPCC report, its implications, and the work currently underway to combat climate change at our website, fisheries.noaa.gov. I'm John Sheehan, and this has been Dive In with NOAA Fisheries.